Hello and welcome back to this channel, Intellimaths. In today's video, we'll be moving forward where we stop in number-based system. On the previous video, which is the part 1 of this video, we talk about conversions from one base to another. We solved different examples and to ensure that we understand the concepts better. In the previous video, do not forget, I gave us an exercise. The solution to the exercise given to us is on your screen. As you can see, it's being displayed. That is the solution and that is the answer. In case you attempt the question but you fail to get the answer, here is the solution for you on the screen. Now, let's move to today's topic. We will be dealing with arithmetic operations in number basis. We'll deal with the basic arithmetic operation in number basis. We are all conversant with base 10 and some of us got knowledge of base 2. But let's see how we perform arithmetic operation in number basis. In this video, we'll be dealing with additions and subtractions. In order to make it simple for us, like I promise to make mathematics solution looks and seems the most simple for us, I will start with the base that we are all conversant with, which is base 10. Then we'll move from base 10 to other bases. I want you to pay close attention to the techniques that we're going to approach to solve the solution. It is quite simple, but it is quite unfortunate that many of us, even graduates, they were just fortunate that the exams they've written doesn't touch some of these questions. And I'm telling you, many people find it difficult to solve arithmetic operations in number bases other than 10 and 2. Today, I'm going to demystify this for us. Let's get started. Like I said, we are going to start with the basis that we understand, which is base 10. Look at this question. Examples. Add 639 plus 683 in base 10. You have to add 639, 639 and 683 in base 10. This will be quite simple for us because we are conversant with addition in base 10. Look at it. 639, 683. 9 plus 3. That is what? That is 12. We understand, every one of us understand quite all right that we write 2 and we keep 1. What brings about this one? Many of us cannot explain. And that is the rudiment, that is the foundation of the problem we have in solving arithmetic operation in other bases. Stay tuned to this video as I'm going to explain and demystify the mystery behind this one that will keep to us. 3 plus 8, that is 11. We say plus this one will give us 12. Then we write 2. We still keep 1. 6 plus 6, that is 12. Plus 1 that we keep, that is 13. Then we now say our answer is 1322 in base 10. Now look at this. In base 10, don't forget we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, if we want to continue with the numbering system in base 10, we say we have 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. When we get to 20, we continue like that. Now, let's come back to the one we keep here. When you say 9 plus 3, that is 12, which exceed the threshold of digits that we could get in base 10. That means we have one set of 10 from that result. And what are we left with? We are left with 2. We write the remainder. And we have one set of 10. This one that we write means one set of 10. This this explanation, what I explained is very crucial for us to understand how to solve basic arithmetic operation in other bases. You will get it right when we get to solving arithmetic operation in other bases. Let's solve another example. This will not be in base 10, but it will be in base 2. Add 1011 plus 1011 in base 2. Look at this. Add 1011 plus 1011 in base 2. Let's get it done. 1011, then 1011 in base 2. Now, when we say 1 plus 1, that is 2. Don't forget, we are performing this operation in base 2. And 1 plus 1, which give us 2, has exceed the threshold of digits we could get in base 2, because base 2 digits are 0 and 1. Now, what do we say in this regard? We have one set of 2, because 1 plus 1 give us 2. That we have one set of 2. What are we left with? We are left with 0. Now, 1 plus 1 here give us 2, plus the one we've kept, one set of 2 that we kept outside. That is 3. 3s are also exceeded the threshold of the digit we could get in base 2. But from 3, we have one set of 2, then we have 1 as remainder. We are going to write that 1 that remains, because 1 is still within the threshold of digit we could get in binary. We write 1. All right, but we still have one set of 2 outside. 0 plus 0, that's 0. Plus 1 that we have, one set of 2 that we have outside, we write 1. And 1 plus 1 is what? That's 2. We cannot write it because it has exceeded the threshold of the digits we could get in binary. That is base 2. Then that means we have one set of 2 and our remainder is 0. Then we write 0. We write 0. Then we bring, since this is the last arithmetic operation in this context, we bring the one that we kept outside here. Then our answer is 10110 in base 2. If you see the same context of base 10, when you want to keep one outside, you turn that one is set of 10. But in base 2, it is set of 2. and so on and so forth. Let's solve another example on a number base that we are not conversant with. We are conversant with 10, and we are conversant to some extent with base 2 also. Let's solve another example on other base other than base 2 and base 10. Example 3. Let's add 153, 15. Let's add 153 plus 216 in base 7, 216 in base 7. 153 and 216. 3 plus 6, that is 9. That exceeds the number of the threshold of digits we could find in base 7. That means we have one set of 7. So when we deduct 7 from 9, what do we have left? 2. The remainder is what we're going to write here, which is 2. Now, 5 plus 1, 6, plus 1 that we have outside, that is 7. That is, we have one threshold of 7 again. Remainder 0. We write 0. 1 plus 2, that's 3. Plus this one, that is 4. That means 153 plus 216 in base 7 will give us 402. So that is that about addition operation in number bases. So this approach is applicable to any addition operation you want to perform in any number base. Now let's move on to subtraction operation. Subtraction. Now we have this will be the fourth example now. Subtract. Let's firstly deal with the base 10 that we are conversant with. 223 minus 186 in base 10. We're going to subtract 223 minus 186. Let's get it done. That's 223 186. 3 minus 6 is going to give us a negative result, which we don't need, which is not needed here. Now, to get a positive answer, we look at the number, the next digit in the column, in the 10 column. So we borrow 1 from there. That 1 we turn to the base, which is 10. Then 10 added to 3 will give us 13. When we now deduct 6 from 13, then we get 7. Don't forget, we have 2 here, but we've borrowed 1 here, which we used here. So we are left with 1 here. 1 minus 8, it won't give us a positive answer also. So we move on to the next digit by the left. We borrowed another 1, turn it to 10, add it to the 1 we have left here. That is 11. 11 minus 8, that is what? That is 3. So we have 1 left here. 1 minus 1, that will give us 0. So that means 223 minus 186 in base 10 will give us 37 in base 10. So let's solve another example, another subtraction example, but this will be in base 2. Let's call this example 5 and subtract 110 1 minus 1 in base 2. 1101 1. Okay. Look at this. 1 minus 1. That will give us 0. 0 minus 1. The answer will not be positive. So we need to borrow 1 from the next digit by the left. So when we borrow 1 from here, we turn it to the base, which is 2, and we add it here. 2 plus 0, that is 2. 2 minus 1, that will give us 1. Don't forget we've used this 1. Then we are left with 0 here. 0 plus 0 minus 0 will give us 0. 1 minus 0, that's 1 in base 2. That means 1101 minus 11 in base 2 will give us 1010 in base 2. So next, let's solve subtraction operation in another base other than base 10 and base 2. Who's calling me? Let me silence this phone. So subtract 5117 minus 324 in base 8. 5117 minus 324 in base 8. Look at the bases. 7 minus 4 will give us 3. 1 minus 2, we have to borrow 1 from the next digit. Now when we borrow 1 here, we turn it to 8, which is the base, and we add it here. That will now give us 9. 9 minus 2 will give us 7. We have 0 left here. We borrow 1 here, we turn it to 8. Add it to 0 that is left here, that is 8. 8 minus 3 will give us 5. And we are left with 4 here. That means 5117 minus 324 in base 8 will give us 4573 in base 8. It is as simple as this. Following this procedure, I will make this video to be as short as possible so that you won't get bored. And the next video will be dealing with multiplication and division in number basis. Multiplication and division operation in number basis. That will be part 3 of this video. And the previous video we deal about conversion. If you haven't watched that video, you can click on the link you are seeing above to watch the conversion, how to convert from one base to another. That's the part 1 of this video. And before we go, I don't just want you to take me for my word. Like, oh, I've shown you the procedure and that's it. You don't, in mathematics, you don't need to cram. Just understand the process and try to confirm if you are right, then you are good to go. I want us to prove that our answer is correct. What are we going to do? Let's see if we convert this number in base 8 to 10 and we convert this number in base 8 to 10 also. We're now going to perform the subtraction operation in base 10. The answer we get, we're going to convert that answer back to base 8. If this procedure is correct, we must get this answer. But trust me, this explanation I want to give you now is just for us to be rest assured that our approach is correct. Nobody will want to use that. Imagine you are to solve a question which you have 30 seconds to spend. Going through that process will waste the whole of your time. But for the purpose of learning, I want us to prove that this short approach that we use is the most efficient and the most simple and the fastest means of solving arithmetic operation in number-based system. Now, let's firstly convert 5117 in base 8 to 10. That it will be equal to 5 times 8 raised to power 3. Don't forget 0, 1, 2, 3. Then plus 1 times 8 raised to power 2 plus 1 times 8 raised to power 1, then plus 7 times 8 raised to power of 0. 5 times 8 raised to power of 3. That is 8 times 8 will give us 64. 64 times 8 will give us 512 plus 1 times 8 raised to power 2 will give us 64. Then plus 1 times 8 raised to power 1 will give us 8 plus 7 times 8 raised to power of 0 will give us 1. Now, 5 times 512. Let's do it here. 512 times 5. This is 10. That's 0, 1. 5, 6. 5 times 5, 25. We have 2560 plus 1 times 64, 64. Plus 1 times 8, 8. Plus 7 times 1, that is 7. Okay? 2560 plus 64. We have 4, 12. We have 2624 plus, okay, that's 2624 plus 8. We have 2, with 3, 6, then 2632 plus 7. We have 9362. Okay, we have 2639. This is in base 10. So the next thing now, we're going to convert this 3 to 4. Also, we're going to convert it to base 10. 3 to 4 in base 8. Let's convert it to base 10. We have 3 times 8 raised to power of 2 plus 2 times 8 raised to power of 1, then plus 4 times 8 raised to power of 0. This is 3 times 64 plus 2 times 8 plus 4 times 1. 64 times 3 is going to give us 192. Then plus 2 times 8 will give us 16. Then plus 4 times 1 will give us 4. Let's say 192. This plus this will give us 16 plus 4 will give us 20. 192 plus 20. 2. This is 212 in base 10. Now, let's now perform the subtraction operation between these two base 10 equivalents. This will now be 2639, then minus 212. Both are in base 10. 9 minus 2, that is 7. 3 minus 1, that is 2. 6 minus 2, that is 4. Then 2. 2 minus 0, of course, is 2. Then we have 2427 in base 10. All right. Now, in order to now get our final answer, you can see that we've performed the subtraction operation in the base 10 equivalent, and we get this. We will now convert this back to base 8. Let's see what we're going to get. Now, don't forget, okay, let's do it here so that we'll be able to compare our answer easily. Let's do it here. So, 2427 in base 10. We want to convert it to base 8. Then we divide by 8. Then we record the remainder here. Now, 2427 divided by 8. Let's check it out. So, let's firstly pick 24. All right. So, 24 divided by 8, that's 3. So, 24, 2 divided by 8, that's 0. We merge it with 7. 27 divided by 8, that's 3. Now, 303 times 8. This is 24 equal to 8 plus 2. 8 times 0, 0 plus 2, this is 2. This 8 times 3 is 24. That's 24, 24. So 24, 27 minus 24, 24, which it means we have remainder 3. Now, 303 divided by 8. Okay, yeah, 8 in 30. We have 3 also. That's 24. 30 minus 24, that's 6. We put the 6 here. So 63 now divided by 8. 63 divided by 8, that is 7. So remainder 7. So because let's do the let's clarify it. If you say 37 times 8, 7 times 8 will give us 56. 8 times 3 24. 24 plus 5, that's 29. So if we deduct 29, if we deduct 296 from 303, we borrow 1, we put it. We have 0 here. We cannot borrow anything. We come here, we borrow 1, turn to 10, put it here. We now borrow 1 from here, turn to 10. This will be 13 plus 6. We have 7. We have 9 left here. 9 minus 9, 0. We have 2 left here. 2 minus 2, 0. So that is the remainder of 7. 37 divided by 8. That is 4. Because 8 times 4 will give us 32. And we have 5 as a remainder because 37 minus 32 will give us 5. 4 divided by 8, impossible. We have 0 and remainder 4. We read from bottom to up. That shows 24, 27 in base 10 is equals to 4, 5, 7, 3 in base 8. As you can see, it's the same thing as the answer we get when we perform the subtraction operation directly in the base. We just use this to prove our answer that our approach here is very correct, 100%. So that is that about that. To learn more about conversion from one base to another, like I said earlier, go to the part 1 of this video. Then you learn much more about how to perform conversion from one base to another. So we get to the end of this video for today. Don't forget to subscribe to our channel and click the notification bell so as to receive updates whenever we release new video about mathematics. Our aim is to make sure you do develop intelligence in mathematics. Don't forget to follow us on our social media platform. We are on Facebook, we are on Instagram, and we are on TikTok at Intellimaths Pro. See you in the next video. Thank you. Subscribe to our channel and ring the notification bell to get our updates in real time. Intellimaths will help you develop intelligence for mathematics.